Good morning, everyone. Welcome to the video series of TFM VPN Labs. In last three videos, we saw how to build a VPN tunnel between Palo Alto firewall and a checkpoint firewall. Then we added more networks over the VPN tunnel, and we were able to see multiple phase 2 essays being created. Then in last video, we used NAT to basically reduce number of essays. Now in this video, we will try to replicate lab number 4, which is for the overlapping networks. So in this lab, we need to make more changes so that we can enable the connectivity for overlapping networks. So let's go through the task first and then we will start the implementation. So task says configure VPN between overlapping networks. This task requires few changes to be done in topology. So we need to create a loopback on R2, then we need to create NAT rules wherever required, and then we need to update the policies. So and then testing, if you see, we need to do this test from the RDP server, which is again in VLAN 122, which is in DMZ of the Palo Alto firewall. So first from internet, we need to reach to this server. Once we are here, then from this RDP server, we will try to access this router and we will create one loopback here on this router R2. So let me quickly verify the configuration on Palo Alto firewall and a checkpoint firewall, and then we can start configuration of this specific task. So I'm logged into Palo Alto, then go to interfaces. So we have one tunnel interface created, we have basic IP address configuration, and then if you go to IPsec tunnels, I could see still the tunnel is up, maybe with the old essays which we have for a specific encryption domain. Now let's first create a destination NAT rule so that I can access the RDP server over the internet. So now go to policies first, NAT, and then click on add button, RDP access. So original packet traffic will come from untrust zone, traffic will go to untrust zone. If you have any doubt, you can refer to NAT assignments why destination zone is untrust. So traffic will come from internet. So instead of any, I want to restrict this from my IP address only. I don't want bad people to start brute forcing my Windows machine with dictionary attack. So I'll restrict this access only from my IP address. So I'm going to check my IP address via whatismyip.com. Meanwhile, let's specify destination address as 136, not 136, 203, 115, 100.105. That's my public IP address which will be used for the NATing. IP address is 196.207.71.200. Go to PAN again, specify this IP address /32. So in translated, we need to translate the destination, and the destination would be 136.1.122.106. So let me verify again the RDP server 122.106. Go to again this and click on OK. Let me see if we have a policy in place. So go to security. So I have one policy in place. I just need to modify source IP address in this. So source IP is 196, source zone untrust, destination DMZ, public IP address, application only RDP is allowed and action is permit. So click on OK and commit the changes. So after this change, I should be able to do RDP from internet, and then we will start the configuration of overlapping networks. So we need to do some NAT changes on Palo Alto firewall for this task to be implemented, and then we need to make few changes in checkpoint firewall as well. So let me quickly log into checkpoint firewall, and then we can see if I'm able to reach to that network loopback address which we have created on R2 router. Let me go to my test machine 70.50. Let me connect to that. Username and password I need to specify. Let me go to putty, and the IP address of checkpoint firewall is 70.103. Okay, admin 123, and if I do a ping, I'm able to reach. So this loopback is active on R2. Good. Um, Now do a test from internet for the RDP server, because we need to make all the testing from this RDP server. So we did use 203.115.100.105 as the IP address for the netting. Click on connect, and I'm able to see login prompt from my RDP server. Username for this machine, and then password. Perfect. So now we need to initiate some traffic here to the loopback address. So first thing is, I cannot initiate traffic directly from 136.1.122.106 IP address to 136.1.122.110 IP address, because in that case that is the local subnet for this VLAN, and this will keep on searching the IP address in the DMZ zone. So I need some virtual IP address. So like we did a test in our class this Sunday, we will take one virtual IP address, for example 1.1.1.1.1. We will initiate traffic from this RDP server on one virtual IP address for testing 1.1.1.1. That will come to Palo Alto. On Palo Alto, we will do a source NAT. So all the traffic initiated from 136.1.122 network will be source netted with some virtual IP address in 136.1.121 range. That will come to checkpoint firewall, and then on checkpoint firewall we will do a destination NAT, that any traffic for 1.1.1.1.1 will be translated with this loopback address. So that's something we are going to do first with the help of NAT rules, and then we will update the encryption domain as well as security policies if required to enable this access. So let me go to first Palo Alto NAT policies. So we need to do a source NAT here. So click on add and overlapping NAT rule. So traffic will come from DMZ and traffic will go to VPN zone, because this is a route based VPN. Traffic will come from 136.1.122.106/32 IP address, and it will go to 1.1.1.1/32 address. It will be a dynamic IPN port. Translated address, let's keep that as 136.1.1.117/32. So any traffic leaving out from Palo Alto from this source to this destination will be natted with 136.1.1.117 IP address. Good. Click on OK and go to security policy. Security policy currently I'm referring as any. I don't want to put focus in this lab on security policies. You guys already know how to restrict access, how to build secure security policies. So let's commit this and come to checkpoint firewall. So on checkpoint firewall, go to NAT policies. So traffic will come from 136.1.1.2.1.117 host. So I should see that IP address, that host is being created. Traffic will come for destination IP address as 1.1.1.1, and then we will translate the destination IP address to 136.1.122.110. Okay, so that's the destination NAT rule. Let me see the security policy here. Security policy should have that host, which is 136.1.1.1.1.7, and then 1.1.1.1 should be there in the destination field. 1.1.1.1.1 as the destination, and let me verify the topology. 136.1.1.26 network, go to topology, and then view. We should have 136.1.1.2 network behind this interface. That's good. So all good as per topology, NAT rules and security policy is concerned. Now we need to make changes in encryption domain of Palo Alto and Checkpoint Firewall. So go back to Palo Alto, networks and IPsec tunnel. So click on this, go to proxy ID, and now proxy ID is, for example, pan-cp local. So traffic will come from 136.1.1.2.106 IP address. It will go to 1.1.1.1/32. That's good. Okay and okay. I want to verify the routing as well. If we are routing 1.1.1.1 towards tunnel interface, so go to static routes. 1.1.1.1, no route is there, so let me add that. Overlapping, and then 1.1.1.1/32, none, and tunnel interface will be the next hop. Okay. Security policy, we have any NAT rule is there, routing is there, encryption domain has been modified, so commit the changes. Go to checkpoint. So my firewall, TFM CP, go to topology, and we need to update this. So I have couple of groups basically, so we need to verify those groups first, what is there. So VPN domain says this network not required, and then overlapping network says okay. So for me, for the checkpoint firewall, local is 136.1.1.1.122.1.1.1.0, for example. So let me go to overlap test, what is there. Yes. So for me, local is 136.1.1.22.1.1.1.0 and the netted IP address, which is 1.1.1.1. That's perfect. So go to TFMCP topology and specify this overlapping test as the group. And for remote, traffic will be coming from 136.1.1.2.1.1.7. Go to overlapping networks, for example, and that is there 1.2.1.1.1.7. Go to pan object here and specify this encryption domain, because the traffic from the pan will come from this netted IP address. Okay. Policy is up to date. Click on install policy. I want to reset the tunnel, VPN space TU on the checkpoint, and then take a basically new session for the Palo Alto 192.168.70.104, admin as the username and password as admin. So let me quickly clear tunnels on checkpoint. You should not use 0 in your production environment. You guys know why you should not use this, because this will delete all the tunnels. So you have to reset the tunnel for specific IKE peers. Go to Palo Alto and then clear IKE, not clear, clear VPN IKE essays and clear VPN IPsec essays. Perfect. Now we need to take RDP from internet. Okay. And password. One thing I want to verify before I make testing. So in Gaia, I should see a route back to tunnel interface for 136.1.1.2.1.1.7. Yes, that's exist. So try to ping 1.1.1.1. First drop might be because tunnel is being renegotiated, but I don't see a response back, so some issue is there. So let's verify. Let's do the troubleshooting why tunnel has not come up. So let me quickly go to checkpoint, open tracker and see if we can see the negotiation or any logs. So I'm on the CLI2 on the checkpoint firewall, VPN TU. I do no phase 1, no phase 2. Okay, so something might be on Palo Alto. Go to monitor and let's see what is happening here. For destination we can put the filter as 1.1.1.1. So today's 28th, yeah, that's today's log. And we do see traffic is getting nutted. We do see 1.1.1.1 and traffic is being allowed. Okay. So there was an issue with tunnel interface. I was able to see this log in the checkpoint firewall which says tunnel interface failed to attach. So I have recreated a tunnel interface. So rest everything is same. Now I'm going back to RDP machine and try to do a test 1.1.1.1. And I can see a response back. So let's verify that in logs. I'm on checkpoint test machine, VPN TU. We should see basically phase 1 up and phase 2 up. If there is a response, checkpoint don't know, for some reason responding slow today. Let's wait. So phase 1 is up, phase 2 is up. Go to Palo Alto, show VPN IKE SA, phase 1 and phase 2 both are up. So if you verify that in logs too, traffic is getting decrypted and interesting stuff here. Encryption domain. It has been negotiated between 1.1.1.1 and 136.1.122.106. That's good thing. So that's all for this video. Thank you very much for watching this video and I hope you are enjoying this video series from Troika System. Thank you very much.